Our universe is a vast and mysterious place, filled with wonders that boggle the mind and stretch the imagination. It's filled with billions of galaxies, each one a sprawling collection of stars, planets, and cosmic dust. Each galaxy contains billions of stars, some of which may host planets with conditions ripe for life. But have you ever wondered where it all came from? How did this magnificent tapestry of celestial bodies come into existence? How did this incredible expanse of space, time, and matter begin? The story of our universe's origin is as fascinating as it is complex. The answer, most scientists believe, lies in an event called the Big Bang. This monumental event set the stage for everything we see today. Imagine a time about 13.8 billion years ago. The universe as we know it didn't exist. There was no universe as we know it, no stars, no planets, not even empty space. It was a time before time, a void of nothingness. No stars, no planets, not even empty space. It was a singularity, a point of infinite density and temperature. Everything that is was compressed into a point smaller than an atom. This point, known as a singularity, held all the energy and matter of the universe. This point was incredibly hot and dense, beyond anything we can truly comprehend. Then it happened, the Big Bang. In an instant, this singularity began to expand. The Big Bang wasn't an explosion in the traditional sense. It was an expansion, a rapid stretching of space itself, creating the fabric of our universe. Imagine a tiny balloon suddenly inflating to an enormous size. That's a bit like what happened. This expansion was incredibly rapid, occurring in a fraction of a second. As the universe expanded, it cooled, and energy began to transform into matter. Particles formed, eventually leading to the creation of atoms. The Big Bang is the best explanation we have for the origin of our universe. It provides a framework for understanding how everything began. It's supported by a wealth of evidence, including the observation that galaxies are moving apart from each other. This movement suggests that the universe is still expanding. The Big Bang is the foundation of our understanding of the cosmos. It explains not only the origin of the universe, but also its ongoing evolution and expansion. The first second after the Big Bang was a time of incredible violence and change. In this fleeting moment, the universe underwent a dramatic transformation, setting the stage for everything that would follow. Imagine a universe so young that even time itself was just beginning to unfurl. In the blink of an eye, the universe expanded at an astonishing rate. It grew from something smaller than an atom to an expanse billions of times larger than our solar system. This period, known as inflation, laid the groundwork for the large-scale structure of the universe we see today. At first, the universe was a chaotic soup of energy and fundamental particles. Temperatures were unimaginably high, trillions of times hotter than the core of the sun. It was a realm governed by laws of physics that we are only beginning to comprehend. But even in this chaotic environment, order began to emerge. As the universe cooled, energy began to condense into matter and antimatter, the building blocks of everything we see around us. It was a cosmic dance of creation and annihilation, a battle between matter and its opposite. As the universe continued to expand and cool, a remarkable transformation took place. The primordial soup of energy and particles began to settle down, giving rise to the building blocks of matter as we know them. Imagine a cosmic kitchen where the ingredients for stars, planets, and even life itself were being cooked up. First came the formation of quarks, the tiny particles that make up protons and neutrons. These quarks, bound together by the strong force, combined to form the first protons and neutrons. It was a crucial step in the evolution of matter. With the formation of protons and neutrons, the universe was now populated with the building blocks of atoms. But the universe was still too hot for atoms to form. Electrons, those negatively charged particles, zipped around at incredible speeds, constantly colliding with other particles. However, as the universe continued to cool, a critical threshold was reached. Around 380,000 years after the Big Bang, the temperature had dropped enough for electrons to be captured by protons. This marked the birth of the first atoms, primarily hydrogen and helium. Section 4. The Cosmic Dark Ages, awaiting the first light. With the formation of atoms, the universe entered a new era known as the Cosmic Dark Ages. This epoch marked a significant shift from the searing heat of the Big Bang to a cooler, more stable state. As the universe expanded and cooled, protons and electrons combined to form neutral hydrogen atoms, setting the stage for this dark and mysterious period. This period, lasting hundreds of millions of years, is shrouded in darkness, a time before the first stars ignited and illuminated the cosmos. The universe was a vast, cold expanse, devoid of the light and warmth that stars would eventually bring. It was a time of profound stillness, where the only activity was the slow, inexorable pull of gravity. Imagine a universe cloaked in a veil of neutral hydrogen, a time of relative calm before the next grand chapter in cosmic evolution. This hydrogen fog was pervasive, filling the cosmos and blocking any light from traveling freely. It was a universe in waiting, poised on the brink of a dramatic transformation. During the Dark Ages, the universe was filled with a diffuse fog of hydrogen and helium gas. These primordial elements, forged in the crucible of the Big Bang, were the building blocks of everything that would come later. The gas was spread thinly across the universe, creating a uniform backdrop against which the first structures would begin to form. Light from the early universe was trapped within this fog, unable to travel freely. The universe was opaque, with photons constantly scattering off electrons and protons. This scattering prevented light from moving in straight lines, creating a cosmic fog that obscured everything within it. It was a time of relative uniformity, a blank canvas awaiting the brushstrokes of gravity. The universe was remarkably homogeneous, with matter evenly distributed across vast distances. This uniformity was a crucial feature, setting the stage for the formation of the first cosmic structures. But even in this darkness, gravity was at work, silently shaping the universe. Gravity, the fundamental force that governs the motion of celestial bodies, was beginning to exert its influence. It pulled matter together, creating tiny fluctuations in density that would grow over time. Tiny fluctuations in the density of matter, present since the Big Bang, began to grow under gravity's relentless pull. These fluctuations were the seeds of future galaxies, clusters, and superclusters. Over millions of years, gravity amplified these small differences, leading to the formation of increasingly complex structures. These regions of slightly higher density would eventually become the seeds of galaxies. As matter continued to clump together, these dense regions grew larger and more pronounced. They would become the birthplaces of the first stars and galaxies, igniting the universe with light and energy. The Dark Ages represent a crucial but enigmatic period in the history of the universe. It was a time of profound change where the universe transitioned from a hot, dense state to a cooler, more structured one. This period laid the groundwork for everything that would follow, from the formation of the first stars to the development of galaxies and galaxy clusters. It was a time of transition, a bridge between the hot, chaotic early universe and the structured, luminous cosmos we observe today. The Dark Ages were a pivotal chapter in the story of the universe, marking the end of one era and the beginning of another. As the first light began to break through the darkness, the universe was forever changed, setting the stage for the rich and diverse cosmos we see now. Section 5. Let There Be Light, the Dawn of Stars. After hundreds of millions of years of darkness, the universe was about to enter a new era, an era of light and brilliance. This period, known as the Cosmic Dawn, was a transformative epoch in the history of the cosmos. The Cosmic Dawn marked the birth of the first stars, colossal balls of hydrogen and helium that would forever alter the course of cosmic evolution. These stars were the first sources of light in a universe that had been shrouded in darkness since the Big Bang. Imagine a universe where darkness reigned supreme, suddenly ablaze with the light of a billion suns. This sudden illumination was not just a visual spectacle, it was a fundamental shift in the universe's structure and dynamics. Within the dense clouds of hydrogen and helium, gravity continued to draw matter together. These clouds, remnants of the primordial universe, were the cradles of the first stars. As these clouds collapsed, they became denser and hotter, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores. This process of nuclear fusion was the engine that powered the first stars. converting hydrogen into helium and releasing vast amounts of energy. The first stars were born. These stars, known as population 3 stars, were unique in many ways. These early stars were unlike any we see today. They were massive, hundreds of times larger than our sun, and incredibly luminous. Their sheer size and brightness made them short-lived but immensely influential. They were massive, hundreds of times larger than our sun, and incredibly luminous. Their immense gravitational pull and intense radiation began to shape the surrounding environment, influencing the formation of subsequent generations of stars and galaxies. They burned hot and fast, exhausting their nuclear fuel in just a few million years. Unlike the stars we see today, which can burn for billions of years, these early stars had relatively short lifespans. But in their short lives, they left an indelible mark on the universe. When these stars exhausted their fuel, they ended their lives in spectacular supernova explosions, dispersing heavy elements into the surrounding space. The light from these first stars, traveling for billions of years, eventually reached Earth, providing astronomers with a glimpse into the early universe. This ancient starlight carries with it the history of the universe's formative years. This starlight, carrying the secrets of the cosmic dawn, is a testament to the power of gravity and the incredible journey of light across time and space. It serves as a cosmic time capsule, allowing us to peer back into the dawn of stars and understand the origins of the universe as we know it today.